All right, let's get this started. Welcome everyone to the second edition of Nomad Virtual Day. Today we'll have a similar format as the previous event that we had. So we'll have a practitioner talking about how they use Nomad in their organization. And then we'll have two more demo-focused talks today, and one of them will be on CI/CD with Nomad, and then the other will be cloud bursting with Nomad. And we'll finish up the day with a Q&A again. So with that, I'd like to welcome on Michael Aldridge of BetterHelp to give us a nice talk on his Nomad experience. Take it away, Michael.
Thank you, Eric. So good morning, everybody. My name is Michael Aldridge. I am a staff systems engineer at BetterHelp, and this is my journey from a co-location facility to cloud-based and dynamic with Nomad. So a little bit about me. I am the Aldridge. This is my handle across everything, and you start to see it pop up when people ask about doing weird things with Nomad and Docker. I run infrastructure at BetterHelp, so I'm responsible for things ranging from our internet-connected soda machine through to our production servers. Go is my favorite programming language, so I really enjoy working on Nomad, things in the HashiCorp stack. It's just a lot of fun. I'm also one of those annoying people who likes to ask why when somebody tells me something is standard. I want to know how it got there, and why is it actually the best choice. For the last 10 years, I've been bouncing around various projects, ranging from a planetarium built on 80s era software to I worked on Google search. Now I'm at BetterHelp. One other place you may have heard from me if you frequent the Orange site is I work on Void Linux in what little spare time I have after work. So a little about BetterHelp. BetterHelp is the world's largest online therapy company by a number of different metrics. Probably the most impressive is that we connect over 100,000 clients each month to over 8,500 different counselors. And in fact, just last week, we passed our 75 millionth online counseling session. I couldn't say it better than is already written here, but our mission is to provide easy, affordable, but most importantly, private access to professional counseling anytime, anywhere. Pretty much anywhere you can get a cell signal, we believe you should be able to talk to a counselor. So before BetterHelp moved on to have Nomad and the Hashi stack, what were we running? We were hosted at a SoftLayer co-location facility in Dallas. We ran on a mix of Ubuntu and CentOS. We had a Chef server. It managed some things. And we had a lot of very interesting code that deployed our primary application stack out onto the fleet. This involved rsync, set UID helpers, shell scripts written in PHP. It was a very interesting process, something that as the company was starting to grow beyond just a single table's worth of developers, we realized needed to change. We did make use of some cloud services at the time, but largely it was based on where things happened to land during prototyping. There wasn't really a grand overall design for our use of cloud at the time. So one of the first steps to becoming a modern operations and systems world is to kind of look at how everybody else is doing it. We chose to containerize all of our applications in order to make this happen. And specifically, we settled on Docker as our containerization system of choice. We chose this primarily because we use Mac laptops for developers, and Docker is extremely well supported on the Mac. It also is extremely well supported on our Linux distribution of choice, Alpine Linux. We really wanted to make sure that applications were self-contained. We needed to be able to simulate exactly what would run in prod on a laptop and ship changes with confidence. We also needed to be able to say that there was an atomic state transition. Using our rsync deployment method, there was always some question about what happened when files were mid-copy and a request came in. Last, but perhaps most important, in a business where we deal with sensitive information, we needed to make sure that our process was easier to understand for our auditors so that they could confidently verify that we were following best practices and that we were taking good care of customer data. So obviously, my organization settled on Nomad, or I wouldn't be here speaking with you today. But it's probably a good thing to take a few steps into why we chose Nomad. There are, of course, many cluster schedulers available. So we started looking at what are our language investments. We have significant investments in PHP 7 and JavaScript. That's what our primary application stack is built in. To the best of my knowledge, nobody's yet built a cluster scheduler in PHP. And if they did, it's probably not something that's going to gain a huge amount of traction at this point in a world where we have a few major players that are already established. We had a Chef server, so we did have some investment in Ruby, but this server was much more pet than orchestrator. It required a lot of babysitting, and Chef is one of those things that works really well if you can make your problem look like something that Chef does well. Unfortunately, we were having a lot of trouble making what we wanted to do look like a Chef problem. My background is heavily in Go. It is my favorite programming language, and I use it in probably more places than it's appropriate. But that's the language I like to use. I also like to claim an allergy to Java, so that kind of ruled out several other options. So if we're looking now for a cluster scheduler that's written in Go, that kind of brings us down to two choices. We have HashiCorp Nomad, and we have Kubernetes. The other major requirement that we had was to be able to run literally everything on one platform. And this really involved needing to reduce the maintenance overhead of whatever solution we ultimately selected. To that end, we looked at running Nomad as our preferred solution. I'm aware of many teams that run Kubernetes and do incredible things with it, but they're also staffed with more people than my team. And I've heard horror stories about what happens when it doesn't go well. To date, we've only had one major Nomad outage, and we attribute this to the simplicity and elegance of which the Nomad solution is implemented. It's something that my team maintains with relative ease. So when I mention that we run the Hashi stack, my team runs the entire run layer of the HashiCorp suite. We run Nomad, Consul, and Vault. We do so with 3 engineers, all of whom are fractional. For attendees who are outside of the interesting world of the Bay Area, that means that none of us have this as our full-time job. We do this in addition to maintaining other systems, consulting on other projects, and generally handling whatever comes up at the time. We run all of our software on Alpine Linux, not only in our containers, but also on our servers. This means that we develop our own custom packages for the operating system, and that's how we handle our updates. We do deploys, application management, and some troubleshooting as a self-service option exposed to our product development team. There are some tasks, though, that of course we would like them to come talk to my team, which handles the cluster itself. Tasks like that usually relate to any kind of recovery or outage mitigation. The last bullet point doesn't make a whole lot of sense at this slide, but trust me, it will by the end of this talk. We decouple all of our updates to the platform through a layer cake of isolation. In fact, most of our developers aren't even aware when we're performing server updates because it's entirely transparent to every application running in the cluster. Now, this talk is about Nomad, but I do think it's important to briefly talk about Consul and Vault, because they really are some of the hidden value adds to Nomad. Consul provides us a unified service discovery layer where services that are aware of the Consul API are able to transparently learn where other services are within the cluster. Now, PHP is not necessarily Consul aware, so this is where Consul's party trick of being a DNS server comes in. We can ask our local DNS servers for the cluster where specific names are, and they will be resolved via the Consul service catalog to wherever that Nomad job happens to be running at the time. This is really a powerful thing to no longer worry about where your applications are running. We also use Consul for automatic clustering of Nomad, such that when we add or remove servers, they transparently join the fleet. Our load balancers directly integrate with Consul. This helps us serve only healthy application instances to outside users. And finally, we use Consul's key value store for basic distributed state. Most importantly, it forms the backing store for our Vault cluster. Vault, if you're not aware, is a secret store and authentication platform that integrates well with the HashiCorp suite. We use it to protect our secret configuration data, things like API keys or private keys to push servers. It also serves as our authentication nexus with Okta. Yesterday, during the Nomad office hours, there was a question about single sign-on with various providers for Nomad. Well, you can get very close to single sign-on using Vault. It provides you a single point where you log in, and then you can request tokens for any other HashiCorp service. We also use it in a much more transparent role, something that even my team sometimes forget is happening. Anytime anyone in our organization asks for secret data or controlled access to a subsystem, that request is logged by Vault. Now, we could store these logs locally, but in order to ensure that they have an optimal level of immutability, we actually engage a third-party security vendor and we send our Vault audit logs to them. That way, there's no question. What's in the log is what happened. And this allows us to very easily go back, and if there's ever an interesting event, we can say, well, what happened around that? Who authenticated when? Who was talking to what service? Fortunately, we've never needed to use this capability, but it certainly lets me sleep easier at night knowing it's there. So now we can look at some of our stack by the numbers. In this slide, I'm only going to talk about BetterHelp's primary serving cluster. As Nomad is our unit of engagement with the data center, we have several smaller clusters, but only one large one that serves user traffic. This cluster has between 40 and 80 hosts at any given time. It's scaled dynamically based on load. Regardless of how many hosts we're running, we tend to have about 500 resident tasks that serve anything from user-facing traffic to our Prometheus-based monitoring stack to random small projects that people just need to run somewhere. As I mentioned earlier, we use PHP. Now, one of the fun things about PHP is that it has absolutely no async capability built in. There are various ways that you can fake this capability, and you can get something that looks like async. But the only way to truly get it is to launch your tasks external to the FPM process manager. We use Nomad to handle over 2,000 batch task launches per hour. This allows us to get true async, which happens on our schedule whenever we need it to happen. We can also use Nomad to force launch certain tasks if necessary. We also use another kind of batch task. We increasingly use parameterized batch tasks, which allow us to handle certain events that we don't want to put on a serving thread. We want the user interface to remain responsive, but we also want this slow task to happen in the background. So there are several points within our platform where if you click a button, it will fire off a Nomad dispatch event and a task will spool up somewhere in the cluster. Now, the fun numbers that I like to use are when we switched over to this platform. We saw an almost immediate 60% reduction in raw computing cost, and this allowed us to redistribute that to more specialized services. We were able to use a database as a service product within Amazon Web Services to dramatically reduce our overhead for persistent storage. The other fun number I like to use is how fast we're pushing to this cluster. On average, every workday hour, there are 4 application deploys. Sometimes there are many, many more, to the point that we've had to start batching them and say that you have to wait for a released train to depart the station. Now, all of these are very interesting numbers, and you might wonder, how large is my team? How long did it take us to get here? Is this something that you could duplicate? From start to finish, initial proof of concept to the day we cut over production traffic took 7 months. And during that time, I was the only engineer who was working on this project full time. So this is very much attainable for a small shop. You can have a system that works just like this, and you can reap the benefits from it. It definitely takes some investment from management to understand that you won't have a whole lot to show for it for the first couple of weeks, but you can get there very quickly. So once we had the Nomad system available, we no longer had to handle the day-to-day business of really babysitting the fleet. And that freed us up to do cool stuff. And cool stuff is what I love to do. It's where we take, the resources that are available and then turn it into something truly impressive. One of the cool things that we do it doesn't sound cool at the surface, but we run everything on Docker on Nomad. There is not even a single task anywhere in our production fleet that is not running in a container that Nomad is aware of. And this lets us leverage Nomad fully to do rolling updates, blue-green deployments, canary rollouts, you name it. as I mentioned earlier, we also run all of our async tasks on Nomad. There are no exceptions to this rule. So this allows us to shed batch workload if we need to during a incident, or if we just experience a traffic spike. We can say that batch workload is running at a lower priority, and we simply won't schedule that for a while. We also use automatic security scanning for all of our Docker containers. This is a zero configuration item, and so when a task is launched into the cluster, within 12 hours, security scan results will be available. We run this on a slightly slower pace just to avoid hammering an upstream vulnerability server. As I mentioned, we also run Alpine Linux everywhere. Alpine Linux is quite popular inside of containers, but not many people realize that it is a full-fledged Linux distribution that you can run on your servers as well. Running only one distro allowed us to amortize effort. And finally, we're realizing the Phoenix server model over the next 2 quarters. We're migrating to a fully immutable infrastructure where not only do our applications run in immutable systems, and to deploy a change to the application, you must deploy a new build. We're doing this with our server operating system images as well. So the automatic security scan is based on a tool suite that we've released called the Yurt tools. This is open source. You can deploy it in your Nomad cluster and get this same screen with your tasks. It provides automatic security scanning for Docker containers. It provides us a sanity check when things are out of date, and it allows us to get checks for things that we don't build. For our own code, we run many of these checks at CI time, and we'll block a build if they fail. But for third-party services that we're pulling off the shelf, we need to pull those from, we need some other way to monitor those, and this provides us a way to do that. It also is one of those fantastic tools that we didn't realize when we wrote it, but when you bring this up in a meeting of security folks, they become very happy that this information is all in one place now. We run Alpine Linux everywhere. For those who are not aware, Alpine is a very small Linux distribution. They're focused on security, they're focused on correctness, and they are focused on minimalism. They use the OpenRC init system, and they use the Muscle C library. This allows us to ignore large swaths of vulnerability disclosures as they simply don't apply to our platform. Many vulnerabilities are predicated on the idea that you are running a quote unquote standard Linux distribution, and they make assumptions based on that. Since we run something that's a little bit off the beaten path, we're able to not leverage security by obscurity, but leverage security by minimalism. You can't attack what isn't there. This also meant that we didn't need to build tooling for multiple distributions, since we were already using Alpine for our Docker containers. It just made sense that based on that previous investment, we would use Alpine for the servers as well. Now, this is the interesting thing. This is what I'm truly excited about in the work that my organization has done with Nomad. We are realizing the Phoenix server model, where when a machine has a problem, we don't troubleshoot it. We shut it down and get a new one. The metaphor I like to use here is layers of immutable cake. The small cakes represent individual tasks. You can see them, you can look at them, but unless you're authorized to remove the plastic cover, you can't interact with the cake in a destructive fashion or in a way that would mutate its state. This is fairly well understood, and this is something that many people who use Nomad today are very well versed in. You build your Docker container, you ship it to the cluster, and it's static until you ship a new version. What we're now moving towards is the larger cake underneath. The large cake represents the actual server, which is hosting Nomad. Now, we build on top of a piece of technology called Linux Kit. It does a build based on OCI containers and Docker image files, and allows us to assemble an operating system that is purpose-built. Packer is a fantastic piece of technology, but it's predicated on the idea of self-hosting operating systems, and that's not required for the use case that we're pursuing. We're pursuing the use case where when you need to upgrade the OS image, you reboot the machine. Or even better, since we run on cloud, you simply add new machines and age out the old ones. This also allows us to be much, much more confident when we update various components of our stack. It allows us to say that we can do a blue-green deployment of the entire production image. This is something that saved us more than once from a rather embarrassing outage. So that's all I have for you today. If you'd like to know more, our immutable stack is completely open source. You can deploy it yourself and run on the same technology that we do. More information can be found at www.resinstack.io. As I mentioned, our Automagic security scanner is open source and lives under my namespace on GitHub. Feel free to check it out. And of course, if you'd like to know more about BetterHelp, you can find that out at www.betterhelp.com/about. And if you're interested in solving interesting problems like those you've heard about today, we're always hiring driven people. Thank you. I'll be available to take questions during the panel section.
Right. Thank you so much, Michael. That's super interesting stack that you're running on. So next up, we're going to have Chris Baker talking about Nomad and CI/CD. So if you can unshare, Michael, and Chris, you can hop on the camera. Let's get the second session started. Take it away, Chris.
All right, cool. So here we go. Have my slides up. So I'm going to be talking about developer CI/CD workflows with Nomad and some Nomad integrations. So a little bit of background on CI/CD. So CI/CD refers to continuous integration and continuous deployment, and often includes a step that is called continuous delivery. So you can break these pipelines across multiple products, and you can do them in different ways. But oftentimes what you'll see is continuous integration and delivery together. What that involves, I'm going to talk about this, a lot of this stuff is there's some idea of best practices that may or may not be appropriate for your organization. But I'm going to talk about what sort of the best practice CI/CD or the pure CI/CD looks like, depending on whether whether this is what you may be doing or not. So this is DevOps flame war territory here. So just bear with me a little bit. But CI/CD is what we're targeting regular merges to baseline. So we're continuously integrating our work that we're doing on some feature branch, right, with the baseline. And we're automatically testing it against the clone of production. So testing is one of the things that you're going to hear me talk about numerous times. One of the, in order to do these things continuously, we have this idea that we're going to be doing them automatically. And if we're going to be doing things automatically, then we need to have checks in to make sure it's safe to do them. So testing, automated testing against a clone of production, that's this integration testing. We want to make sure our code is making it back to baseline. Our code is being tested against production. It's safe to be on baseline. We're automatically building. This is delivery here, automatically building against every single commit, right? Continuous deployment is sort of the second half of that. What we have is we have automated or semi-automated deployment of baseline to production, right? So we have this idea that we're regularly taking our code, we're getting it back to master or baseline as soon as possible. We're testing it, we're building it, we're delivering executables, and then as soon as it's safe, as soon as we've determined it's safe, we're getting it over to production. And the benefit of this is very quick turnaround, right? Frequent merging back to baseline is going to minimize complex. We all know what happens if you have these long-lived branches out there with lots of different changes, especially if you have a large team working on multiple things. Automated build process is great. In addition to being automated, click the pull request button and go off and have lunch. Automated typically also implies documented and repeatable, right? The exact opposite of this, I hate to pick at a straw man, but the exact opposite of this, which I'm sure some of you have seen before, is that outage, figure it out, pull the code down, the developer fixes it on their laptop, pushes a Docker image up, and it's running in prod, right? How did that get built? Where's the code for that even, right? These are the sort of things that we want to see answered. We want to know at any given point in time what's running in prod, where the binary came from, how it was built, what version of the code it is, where that code is. We need to have all of these answers, right? And one of the other benefits of continuous integration is, of course, integration errors are caught earlier, right? There are some things that just don't show up until prod. So you want to make your testing environment look as much like prod as possible, whether it's some snapshot of prod or whether it's just using, as close as possible to prod. All of this going towards faster release cycles, right? Faster and safer release cycles. So what does this mean for Nomad? Where does Nomad fit into a CI/CD pipeline? There's a couple of different places. The first one is just as a CI/CD host, right? CI/CD, all of this testing, all of this running stuff involves a number of different tasks. You have to run these somewhere, right? So Nomad can serve a place just right away as the host for the CI/CD pipeline. and for the services that is required, right? If you look at doing integration testing against a clone of prod, against an environment that looks like prod, you're going to need a number of other services. You may need databases, you may need caches, you may need all these other things. So in addition to running the pipelines, you need places to run the services that allow you to do the integration testing. Of course, the natural place that you're probably thinking about for Nomad in the CI/CD pipeline is as the deployment target. At the end of the day, our goal is to deploy our application to a production environment, right? So we need a production environment. We probably need multiple environments, right? May need multiple clusters, right? And because these are prod environments, we have all sorts of requirements that come along with these: service level agreements, corporate governance, regulations around what we can store, where we can store it, HIPAA, that sort of stuff. So you need a pipeline, you need a target for your pipeline that's going to support all of these things. Different levels of access control, for example. You want to be able to give your CI/CD pipeline the ability to do only the things that it needs to do and nothing more. You want to make sure your developers have the ability to do the things that they need to do, but not a lot else, right? It doesn't do us any good to have the CI/CD pipeline that automatically puts things out there in the correct way if somebody can accidentally, type the wrong command and delete prod, right? So you want to make sure that you have a full-fledged cluster to support this sort of stuff. And then the third one is as a deployment lifecycle manager. A lot of the CI/CD products out there are built around this. They have these concepts of continuous deployment and deployment lifecycles. So you're going to have support in these for things like blue, green, canary. Nomad also has these as well. So different strategies, you may find that you're gonna be using them in place of the built-in capabilities. You might find that you'll be using them in concert of. You'll get an example of this later on in my demo. So let's talk about some of the specific Nomad CI/CD features. Dispatch and periodic jobs. You heard some mention about dispatch jobs and their use during the previous talk. So dispatch jobs allow you to go ahead and take some parameters of a generic template job and execute some child of that job with those specific parameters. You can imagine, immediately imagine that this would be very useful for kicking off these sort of batch things like build, release pipelines. And you can access these, for example, from source control webhooks like GitHub or chat ops, right? I can go into Slack and I can say, hey, run build 17, or run build against this Git SHA. Kick this off, right? So this is the sort of thing that you can build with Nomad or use from Nomad in a CI/CD pipeline tool. Another one is periodic jobs. This is an obvious candidate for something like nightly end-to-end or integration testing, or things like automated branch merging, right? Again, a lot of these things are capabilities that are built into existing CI/CD tools, but we have them in Nomad as well. So depending on where you want to go, how much of this you want to build yourself, how much of this you want to hand off to another pipeline. We have a lot of flexibility here. Nomad deployments, I mentioned application lifecycle. So our deployments have the ability to, Nomad has the ability to do application lifecycle deployment, so advanced deployment strategies. You can have Nomad do this sort of stuff. When I update my job, how do I want to update my job? Do I want to do a rolling deployment? Do I want to do something like a blue-green? Do I want to do canary? So these are built into Nomad. Again, I'll go over some of these in my demo. And then all of the sort of capabilities that you need from a cluster when you're trying to do, proper production level deployment, right? Cluster federation is built into Nomad. Access control list is built in Nomad. Policy enforcement is available in Nomad to make sure that you're doing the right thing, you're deploying the right thing. And then, of course, the best part about Nomad is HashiStack integration. Integration with Terraform, with Vault, with Consul, right? Consul for service discovery, Consul Connect for service mesh, Vault for secrets management. Secrets management is never more important than in the CID pipeline, where we have these automated tools out here that are trying to do things. We don't necessarily want to be baking our secrets into these scripts, right? That's not how we want to. So we need to make sure that we have the ability to get the information to these pipelines in a safe way, a best practice way, and make them available to these pipelines just in time so that they can do what they need to do, but only what they need to do. Furthermore, for day 2 operations and later on, we have other tools like the Nomad Autoscaler, for example, for managing your application scaling. So let's go ahead and kick into a demo, right? So this talk was directed towards developers. So let's go ahead straight into where the developers live, the developer workflow. Let's go into the code. What I have here is I have a repo up on GitLab. This demo is on GitLab, by the way. there's a number of different products out here I could have targeted. GitLab is the one that I'm most familiar with, so it was the one I could whip up the quickest. But what I've got here is I've got a little web server written in Go. Here's a test file, because we have to have tests. You can't do CI/CD without tests. I'm just going to keep saying that over and over again. And then we have the main routine here. And this is just a simple little web server. When you hit it, it responds to you with the git SHA, the commit SHA for the git commit that this was built against, and then a little version here, which we can manually update. So let's go ahead and walk through what a developer workflow looks like. I'm going to click edit. And this is, well, actually, let's go ahead and show you the app, right? Here's the production app. It's running here in production. I've got these environments registered in GitLab, and production is one of them. It's demo.cgbaker.dev, and you'll see the git SHA, and we're on version 0.17, right? Matching to exactly what it is that we're seeing here on master. So let's go ahead and change that to version 0.18, and what are we going to do? Let's make that a little bigger. Let's turn those into level 3 headers, right? This is all the HTML that I know. So I'm going to say 0.1.8 to H3, and I'm going to say to H3. And we're going to go ahead and create a new branch with this commit and go ahead and start a merge request for this. And we're going to see a number of things that are going to happen here inside of GitLab here. GitLab is going to go ahead and create that branch. The UI created the branch. It created a pull request, same as you would do with GitHub. And then what it did is it automatically kicked off this pipeline. So, and it tells me here, right? It knows by looking at the CI/CD pipeline, it's going to deploy to review to H3. So it's going to go ahead and create what's called an application review, a review application. So if I go and look at this pipeline, you see this pipeline has a couple of different stages. The first is test. The second is build. So test is going to run our tests, in this case, just that version test.go. But this is where you could do more sophisticated things, spin up a database, spin up some snapshot or clone of our production environment, do full end-to-end, whatever is appropriate for a merge request. You get to pick that. You get to decide that based on whatever is appropriate for your application. Then it's going to do a build. This build step is, I'll go ahead and dive down in here. It's going to build the application, and then it's going to save the artifact. It's going to save this demo web app. And it's going to upload that to an artifactory that's built into GitLab. And the second is it's going to do a deploy of the review application. And what this is going to do is going to run a little script, which is going to take a Nomad job template, and it's going to go ahead and fill it out using Levant. If you're not familiar, Levant is a Nomad tool that, among other things, will template out a Nomad job file. So here's the job file for this, and it lets you write these templates, and then we go ahead inside of the script, deploy review, it will use Levant to fill out all the variables that we know from our CI/CD pipeline against this. And what is it going to do? Well, it's actually going to go create a new job in Nomad. So if we go back to our Nomad cluster here and go to jobs, you'll see we have this new review app here. And it's registered with Consul. It was automatically picked up by Traffic, which is our load balancer. And we see it right here. It's got this brand new domain right here. So if I go and refresh on this pull request, you'll see here that everything is up and ready. It's ready to merge. We can, it's been registered with GitLab here that we have this new environment, review feature to H3, and I can click on it and see that in fact we're on version 0.18. The git SHA is F713A150, which is exactly what we just built. So it looks good. I like it. Y'all like it? I mean, it's much easier to read, I think. We're gonna go ahead and accept this. So I'm going to click merge. So what happens when I click merge? Well, two things happen. The first thing is that we've merged these changes to master. So what we're going to do is we're going to kick off another pipeline for master, right? So if I go and look, we see a couple of different things happening. The first is this new pipeline for master is going to run. It has additional stages. That's because master is special. Master gets deployed to prod. The other thing is this is actually going to go and run a shutdown for that review app. So if I go back to Nomad, you just saw it disappear there. The demo app got removed because we don't need to keep it around anymore. We reviewed it, it looked good. We can spin it back up again using our CI/CD pipeline, but we don't need it right now. It got removed from traffic, so it's going to go away. While the pipeline for master is running, let's go ahead and peek at that. It has an additional stage, like I mentioned. It's going to do tests. Maybe this is a different set of tests because this is master. It is special. It's going to do a build. Brand new build of the artifact. It's a brand new commit because of the merge. And then what it's going to do here is I've got this configured to do a canary deployment. So what it's going to do is it's going to rely on Nomad to manage the application lifecycle, the canary in this case, the canary deployment. So it's going to update this job, and let's go ahead and peek at that job. This is the web app for prod. If you go look at the prod web app, it has an update stanza that specifies it does a canary. And then it has service stanzas that indicate what happens with the canary. And the way I've got it configured, and this is, again, is entirely flexible, is when the canary app gets deployed, if we go look in Nomad, you see we've got an active deployment here. It's got 2 canaries, and then it still has the previous 4 allocations. And we've got a brand new front end registered in our traffic load balancer, canary.demo.cgbaker.dev. We still have prod. Prod has not been touched. Prod is A-OK. It's still running with the same number of instances it had before. But we do have this canary deployment here. The canary deployment has been registered inside of this merge request. We can still look at the same merge request. That's the nice thing about the CI/CD platforms like GitLab, like GitHub Actions, like Spinnaker, is that they give you the ability to register this stuff. I can find this from multiple different places inside of the application. But see, I can still look at the same pull request and see that, this has been deployed to Canary 51 seconds ago. So let's go look at it. Well, it looks fine. It looks exactly the way it was supposed to look, the same way it looked on our application. But this one's running in prod. So this allows us to go look out of band at canary.demo.cgbaker.dev and say, this really is okay, running in prod. We're going to go ahead and approve it. So let's go back. There's a couple of different places to do this, but I can look in production, look at this environment list here and see that 6681B is on Canary. And we're going to go ahead and just deploy that to prod. And what that's going to do is it's going to finish off this pipeline right here, deploy prod. And what that's going to do is it's just going to talk to Nomad, and it's going to go ahead and say, this deployment that's active, I'm going to go ahead and promote it. So you'll see that happen here behind the scenes. The automation did that. And it's going to shut down the Canary instance. It doesn't actually shut them down. It converts the Canary instances over to mainline instances because they're fine. They're already running the right version. And you'll see the rest of the instances, the rest of the allocations get updated to the appropriate version. And we'll see now that we're back to normal again. We've got prod. If I go and refresh the environment here, you'll see that master is running the same version that Canary was running. I can go and open it up, and it's on V018. So that's pretty much the whole lifecycle there: review apps, Canary, and then production deployments with a manual approval. That manual approval doesn't have to be manual. That's the thing that can be automated. Nomad can do that automation. Levant can do that automation. Spinnaker knows how to do that sort of stuff. You can do automated Canary analysis using tools like Kayenta. So the only other thing I wanted to show you from this environment is if we go back and look at the list of jobs in Nomad, you'll see I've got a couple of things. I've got our load balancer running in Nomad. I've got the demo application, so prod and the canaries running in Nomad. And then I also have GitLab runner. So what I have here is I have the actual runner that handles the CI/CD stages for Nomad is also running in the Nomad cluster, and it's registered back with GitLab. So if I go and look at my runners in GitLab, I've turned off the shared runners because I don't want to use the shared runners. I have my own infrastructure. Maybe I have some privacy concerns. So I'm going to turn off the shared runners, but I do have this nice little Nomad runner sitting right in here. And this is one that I manually spun up. We can talk about other integrations in just a second. So that's the end of the demo. What do we have left? What does a roadmap look like? That was just a very brief one, right? Nomad, GitLab. So what is the current state of the world with regard to Nomad CI/CD integrations? Well, you can use the built-in features in Nomad, the out-of-the-box stuff, and go ahead and build whatever you want using your own pipelines. I know many of you already do that, right? So you can do it with GitLab like I did today. You can do it with Jenkins, Travis, you can go write GitHub Actions. So that's one of the things that we want to do going forward is to go ahead and give a library of maybe, best practice or the things that we've discovered, the easier ways to use Nomad with something like GitHub Actions. There is a Nomad Spinnaker Terraform provider. This is a nice one. Armory wrote this. So you can actually use Terraform stages inside of Spinnaker. And because there is a Terraform provider for Nomad, that means you can do Nomad deployments via Spinnaker. But one of the things that we're actively working on right now is first-class support in Spinnaker for Nomad, so that you can not only run Spinnaker and all of the stages on top of Nomad, but you can use Nomad as a deployment target. A Nomad GitLab runner, or first-class Nomad GitLab runner, that handles auto scaling of the runners and everything else is something that I want to work on. Like I said, better examples for GitHub Actions. And then we'd really like to get into some Nomad chat op examples for things like Slack. So you can, for those of you who are interested in chat ops or just the reporting into Slack, we can make that work. Thank you.
Thank you, Chris. That was an awesome demo. Next time I have CI/CD issues, I know who to find. So next up would be me. So let me share my screen and then take it away. Oh, why? Old panelist. Oh, I have some new things. Share. There we go. All right, so that should be working now. Let me turn off the camera so you get a bit more screen real estate. All right, so I will be talking about how to do cloud bursting with Nomad and Consul, but without all the difficult bits that normally come with cloud bursting. We'll just skip this because nobody cares about me. Now, you might all remember cloud bursting as this magical destination that was all the hype a few years ago. And then it quietly died away and you don't hear a lot of people talking about it anymore. But the idea was that we would still have our on-prem data centers, and then we would leverage the cloud to provide us additional elastic capacity. So we could scale up when the load on-prem exceeded its limits, and then scale back down when we didn't have load or it was very low. Now, the main reason people wanted to use cloud bursting was to save money. And by not having to add the additional hardware in their data centers, but just keeping a safe minimum of hardware that could handle their normal loads, then they could actually scale down slightly. And then cloud would give that extra needed capacity if they needed to scale up and down for the unforeseen spikes that might be there. And then some other use cases could include accommodating bursty workloads, such as batch jobs for, say, for instance, data analytics or machine learning. But in this day and age, with everybody trying to move to cloud, is cloud bursting still relevant? Well, with everything that's been going on right now, there has been a real need to suddenly scale up capacity for a lot of internet-facing companies. You might have seen some headlines such as these about Zoom, Google Meet, Microsoft Teams, etc., having to scale up to insane amounts of daily meeting participants. And with everybody stuck at home, live streaming numbers are crazy. Twitch has seen a huge increase in viewers. And since we all need toilet paper, Amazon has posted $75 billion in revenue, and that's just for the first quarter. Overall, internet usage is up about 70%, and with that, streaming is up more than 12%. And that was just the numbers from March. Now, being able to handle these sudden and huge increases in load is an amazing feat of engineering. So first of all, a big thank you to all of the internet-facing companies that have helped us get through this time. And for me, this mainly means Netflix, which has not failed me once, to the point that I'm now running out of content to watch. So thank you for that new problem. The thing is, though, that these companies are specifically geared towards using the best of cloud. But what about the companies that are not? Also, those companies have had to scale, but they might not have been as ready for it. For many people, use cloud is not just the flip of a switch, but instead it's an 18-month-long project that often turns into an even longer journey. And how do these companies handle scaling if they're still on-prem, or maybe they just started the process of migrating? So we're going to be exploring that situation specifically, where we're going to take a pretty common scenario where we have an e-commerce website that needs to scale up way above its regular load. And this is a very common occurrence, right? We have it every year, say, for instance, with Black Friday. And our stack's going to be a monolithic Ruby application that reads data from an SQL database and uses a cache to speed things up. Now, because our application is single-threaded, we need to use a special web server to run our application on so we can have some concurrent requests going in. And then to prevent the slow client problem that is common with the Unicorn web server, we will front it with an Nginx proxy. So that's our 3-tier architecture right there. Now, besides that, we really like when people visit our web shop, but we like it even better when they place orders. And when they do so, they like to receive their packages. So we do that by using batch jobs. So we'll have a batch job that'll grab an order from a queue. It'll process it. It'll call some API on the FedEx side. And then after that's all done, processing will store the result in a database. Now, our web shop has a fairly standard daily trend where everybody wakes up, people start to buy things around 10, 12. It's the older people that are not at work that are still buying some. People come home and it increases a bit. Kids go to bed. Then around 9, 10 in the evening is when people start to hit their wine saturation and all those impulse buys happen. And you start buying those things that you regret in the morning or that you forgot about entirely, and then it arrives at the door and you have to explain it to your spouse. And then at night, all the load goes away and it's quiet, right? So during the day, we want to be serving our web shop. And then in the evening, when it's more quiet, that's traditionally when we would run our batch jobs to send out all the orders. So during normal working days, our instances can handle around 20 requests per second. And we can handle around 10 of those instances per machine, and that's mostly due to memory consumption. But the problem is, though, that we're expecting to get over 20,000 requests per second during peak times, and we only have 50 available machines in our data center, which basically means that we have to effectively double our machine count in order to handle all this traffic. Now, unfortunately, when you buy extra tin for your data center, you cannot unbuy them and scale down when you want to and when you don't need them anymore, like you would in cloud. And scaling up during those peak times actually really matters. Because if you think about it, if we have 100 requests on average that a user makes until they decide to make a purchase or not, and let's say 3% of those people end up actually buying something with an average transaction value of around $30, that means that on Black Friday sales, that's about $666,000 per hour in transactions, which basically means that we would lose $12 million of income over Black Friday, which is around 10% of our annual income. So that's a big deal. Now, what are our options? Well, first of all, we could build out the hardware in the data center, but that's a huge capex for something that will be idle 99% of the year. So we're basically going to be losing money due to the additional hardware costs and run costs. So that's not really an option. Second option, do nothing, fingers crossed, and hope nothing goes wrong. Well, if the traffic does overwhelm our data center, that would basically take down the entire data center, which means we'll have 0 sales, which means we could lose all of that 12 million in income. Well, the obvious choice would be migrate to cloud, right? Well, we don't have 18 months. We only have 6 until Black Friday. The goal is to move to cloud eventually, but we just don't have time for that right now. So cloud bursting is actually our best bet, where we can move maybe some components to the cloud that can easily be scaled up without having to store state, and then just keep all the difficult bits like our data stores in the data center. So that's what I'm going to be showing you. If there are any pepcaks, that's my fault. So this is the situation that we will try to set up. We will have 2 data centers, one on-prem and one in the cloud. We will have a Nomad cluster in both of those. So all of this will be running on top of Nomad. we will have the standard application stack of Nginx, Unicorn, database, and cache running in our on-prem. But when things get too much for the on-prem data center, we actually want to route the request from Nginx to extra Unicorn instances in the cloud. And we want to automatically scale those up. So we will be leveraging the mesh gateways feature to actually do that federation of that traffic. All right, so with that, let's switch over to the editor. I'm actually running this entire demo locally. So that means that my memory is somewhat low. So I'll have to clean my memory halfway through a few times probably, but it does mean that you can actually download this demo and run it for yourself later. So I've already spun up all of the components. Let me first show you the Nomad cluster. So in our Nomad cluster, we have our Nginx talking to the Unicorn service, and then the database and the cache. And then around that, we have Prometheus as our monitoring tool, and Grafana so we can look at pretty dashboards, and then our mesh gateway so we can actually federate over the internet. Now in the cloud region, right now, I only have the mesh gateway running and Prometheus, which is federated to the other side. If we take a look at console, we see that I have already service meshed all these applications. So we see that we have the Unicorn with its sidecar proxy, and I've also service meshed Prometheus and all the other components. So everything is nicely hooked up and everything is now communicating on localhost to themselves. And it's all MTLS encrypted to all the other instances. And here we can see that we're currently running one instance of the Unicorn service, and there's no requests going in there. So let's first take a look at the application and see if that actually works. So there's two ways to do that. I have the UI where we can nicely see the flow, right? So we see a request going from Nginx on-prem to Unicorn on-prem, and then to the database and the cache, right? So this is all working, but it's all on-prem. Now, let's start sending some actual traffic through here so we can see some metrics, right? So let's not start off too enthusiastic. Let's just start off with maybe 10 requests per second and then one concurrently. So if we head over to Grafana, we can see that the manual request that I sent in was already here. Now we have to wait a few seconds. And we can see traffic is slowly going in. And the application can easily handle it. It's no problem, this 10 requests per second, because as we said, it can handle around 20, sometimes a bit more, sometimes a bit less, right? But what happens if we actually start to overwhelm it with requests? Well, let's just try to send in some additional requests. So let's just do 30 requests per second. All right, now we need to wait a second. Waiting on Grafana dashboards is always like watching paint dry. It's never nice. While we're waiting for that, let me just empty some of my memory preemptively so everything will be okay. All right, okay, so here we see extra requests coming in, and we can start seeing that the application is not liking that sudden influx in requests, right? We're seeing some 500 errors. Now, if we get the 20,000 requests that we mentioned in the slides before, it would go down, right? And of course, we would have multiple of these instances running in our data center, but eventually we would hit that cap and we would get outages, right? So just to spare the instances, let's just stop that for a second. Let's start to make use of this other cluster that we have. So we're going to be deploying our Unicorn instance, which is just a simple Docker task. I'm running an exporter for the stats as a sidecar. And then we have our little unicorn application that will be talking to cache and database, right? So it doesn't know anything of where those live. So let's start off by deploying this application and then also deploy the cache application so that when we do a round trip to the database in on-prem, we actually can cache some data in cloud, so we don't have to make that round trip every time, right? All right, so let's do a Nomad run. Let's deploy Unicorn. And then cache as well. All right, so if we head over to the Nomad UI, we now see that the applications are starting up. Everything seems to be going great. But if we go here, we don't see any Unicorn Cloud or whatever. And that's because the service mesh doesn't know that it needs to route some of the requests over the mesh gateway. It just tries to find the closest instance, which would be in the own data center. So we need to add some configuration to actually make this work. So what I'm going to be doing is I'm going to create a resolver for the instance of Unicorn in cloud and on-prem, which is basically like a virtual service. And that way I can actually split the two, right? So I'm going to be applying this one for cloud and then for on-prem. And then to tie those together, I'm going to alter the service resolver for the main Unicorn service, where I'll actually do a failover. If one of those goes down, I'll fail over to the other data center, right? So let's first apply that configuration. So do console config write, test, and then let's do that one. On-prem, and then the generic one. All right, so now that we have this, theoretically, we could have requests go to the other data center. But since the Unicorn instance of on-prem isn't going down, and I'd rather not have to actually take it down and impact all our normal users to be able to test this, I want to find another way to do this. So what I'm going to do is I'm going to create a service router, and I'm going to say that if a request matches the header of X group test, so I'm going to open it up for the test group, I want to instead route just to the cloud instance, right? So let's apply this. Router, okay. So now that that is applied, these requests still work as normal, right? Because we're not sending any headers. But if we do pass in the headers, we should, if I didn't papcac, end up at the cloud instance. So let's do a curl with header of X group test. And we're going to go to localhost because I've bound the Nginx to actually listen on localhost. And let me just pipe that into JQ so it looks more pretty. We can actually see that we're going from Nginx on-prem to the Unicorn instance in the cloud now. And then it's heading back over to fetch some data from the database and then store that in the cache in the cloud. And then new requests could then start using that cache, right? So now we've validated that, okay, the cloud instance of our application actually works. So we can now start to actually send some traffic there, right? Now, what we will do is we will actually add a traffic splitter between these instances of our Unicorn, where we'll be sending, first of all, like 50% of the traffic to on-prem, and then 50% of traffic to the cloud instance, right? And that should automatically then send traffic between these two instances. All right, so we go to node console config, right? So we're going to apply this new configuration that we see here. And this splitter. Now, if we go into the UI, we should see that some of these requests are going to cloud, and then some of these are going to on-prem. If you look here, you can see them actually switching back and forth. So that's great. We're now using the instances in the cloud as well. But if the instance actually gets overwhelmed, that's not going to help us, right? Because if we run our load test again, and let me run that in a different window, and let's say we're going to send, I don't know, 50 requests per second, and we head over to Grafana, we can see that we have 2 instances running. And before they were getting about 1 request per second each. But once the paint dries, we should see that it now scales up. Now, because we only have these 2 instances running, it's not really going to help us, because basically all we've done is just add additional hardware to our data center. Just the part of the data center is now running in the cloud. We want to be using the elasticity of the cloud to actually help us scale up. So what we want to do is we want to make use of the new Nomad autoscaler. So to do that, I'm going to be running the autoscaler on Nomad itself. And I've configured it to talk to the local Nomad agent, and I'm using Prometheus to get metrics so I can scale on those metrics. And what I'll be doing is I'll actually be scaling on metrics from the service mesh. And the reason I do that is every application has its own metrics that it would like to scale on. Some like to scale on connections, others like to scale on requests, and maybe some others would like to scale on CPU usage or something like that. By actually having the metrics from the service mesh, I can individually scale each of those components very easily, and then still end up with routing everything automatically. I'm running the old version of the autoscaler, so you should probably not do that and run a newer one instead. Sorry, James. All right, so let's apply this one. Okay, running the autoscaler. Go here. Autoscaler is healthy, so that looks good. But as we can see here, there's no extra instance coming up. And that's because we actually need to add some stanza to our job. So what we're going to be doing is we're going to add a scaling stanza to our unicorn job. So the only thing that is actually changed is this part. And I want to be scaling up from a minimum of 0, because when there's no load on the on-prem data center, or not that much, I actually don't want anything running in cloud. And the query that I'm actually showing here is actually exactly the same query as is powering this little dashboard here that shows the average request per instance of the application. So I grab the downstream requests for the unicorn application, and then I'm getting the average from that. And I want to have an average of 15 requests per second going to each of these allocations. Now, I have added a max because I don't want it to scale up to infinity and then find out that, well, it's not what I wanted. So I'm going to limit that to 5 just to be sure. All right, so all we have to do is just submit this job. So we're going to submit the unicorn job. And it's going to give me a warning because I already had an instance of the unicorn application running. Now, normally you wouldn't want to do that, but I want to showcase the actual scaling from 0. So this will actually, in my case, give me some 500s because we're actually going to scale down to 0 for a second, and then the autoscaler is going to kick in and actually scale up for us. Now, if we head over to the autoscaler and dig down into the allocation, we can actually see some of these scaling decisions that are being made. Yep, here we go. So here we can see that for the job ID of unicorn, there were some scaling decisions. Now, this is the scaling where it was already scaled down to 0, and it now wants to scale up to 3 because there are more requests than each of those instances should handle. So the scaling factor is 2.1, so Nomad scales up. And then later on, Nomad realized that, okay, that was maybe a bit too much. I can actually just run 2 instances instead of 3. Now, the new version of the autoscaler actually has like a grace period that you can define, so it doesn't scale up as frantically as my demo would. Now, if we head over here, we can actually see that we got the dip here where I scaled to 0, and then the autoscaler kicked in, and now the requests are being nicely spread over these 2 instances. Right, so we have 14 going to cloud and then 13 to on-prem with an average of 13. And we're at about 15 per instance, right? Now, if we let this run long enough, it'll start to equalize, but because we only have 2 instances, it's a bit more fragile than it normally would be. But we are actually going to see only 200s eventually, right? Okay, so now that we can actually have Nomad scale up for us, awesome. We don't have to think about that anymore, but we still want to be running those batch jobs. And when traffic actually goes down, I would actually like to use those dips in traffic to be running those batch jobs also during the day. So I could just do that whenever there's space for that. So let's add that, right? So what we're going to do is we're going to deploy the order batch job. And by default, we're going to have 0 instances of it. And we'll be scaling up to 5 if necessary. Now, this is not the most pretty query you could make, but I'm actually going to be grabbing the number of order tasks that are already running and the number of unicorn tasks that are already running, and then subtract that from 5, right? So I'll always have either 5 or something that fills up the void between what unicorns is running and which space I still have for my order jobs. So let's first deploy the queue application that the order task will need, and then deploy the order tasks. So let's do a Nomad run on that. Make sure that the queue is up and running, and then run our batch job. Now, our batch job will actually use the mesh gateway again to actually communicate over that mesh gateway to the instance of the database in on-prem, right? So we're leveraging all the components that we cannot move to cloud in our on-prem data center and then scaling up from there. So if I play this again, then we can actually see that because we have 3 instances running of the unicorn application, there is still 2 spots left for the order job to run, right? So the order job is using some of that capacity that the unicorn services don't need. Now, what happens if we actually kill all the traffic to these instances, which I'll do just by killing the load test, and we will see the load actually drop down. And then in the Nomad UI, we should actually see this being scaled up to 4 actually, because my query doesn't account for the instance of unicorn still running in the on-prem data center, since I'm federating all those metrics. So we have 2. That's because we still have 2 unicorn instances. We can see that traffic is going down. All right, we're going down to 2 instances. So we actually see the order jobs now actually scaling up. And it won't actually go higher than that. And then Nomad will keep running the order tasks. They'll complete their batch job, what they're supposed to do, and then give back the capacity if needed, right? So if we would increase the traffic again, the number of unicorn instances would increase, the number of order instances would decrease again. So now we have a super flexible system that we can use. So what are some of the next steps? Well, the next step could be to make use of some of the upcoming plugins for the Nomad Autoscaler. For instance, to also scale up the VM instances in the cloud automatically when load is too much and we maybe cannot place some of our unicorn instances in cloud, right? That would give us ultimate flexibility. And the cool thing is actually that by migrating the unicorn application to the cloud, we can now slowly start to migrate other applications. So we could move the Nginx proxy to the cloud. We could just have the cache always running in cloud and just have the data center still on-prem. And then once we're comfortable with moving towards cloud, we just need to create a SQL instance in the cloud, maybe a managed service, ideally. We can then replicate our data there and then eventually, hopefully, turn off the data center entirely. And we now had a pretty smooth transition to running solely in cloud. So as I said, this demo is entirely local, and you can actually run it on your own machine, and I'll be sharing that link with you. So with that, thank you. And we're going to head on to Q&A. Let me stop sharing and everybody can turn on their cameras again. All right. Which apparently is just me.
It says the host has stopped the video.
Which I'm not sharing anymore.
You need
Oh, can we?
Video.
Oh, hold on. Is that some new Zoom thing where only the host can speak? Is that? If I stop my video, can you do video?
You can't start your video because the host has stopped it.
All right. Oh, well, I can fix that. I can, here you go, Chris. I'll, oh, I need to make you a co-host. That's, there we go.
Sweet.
Let me just do that. There we go. Right. There we go. I think we have everybody, and then I can turn it on again as well. All right. So some of the people on the Q&A panel you might have already seen. Well, you have not seen Michael and Chris yet. So Michael Aldrich and Chris Baker. And I'd like to also welcome on Andy James and James Rizal to help us answer questions. And I think Schmeigel is not going to be joining us for now. So, oh, he is. That is good because
Sorry
I
about
actually
that.
heard that you had a question, Michael, for Michael.
Yeah. First of all, thanks to everyone who presented, but thanks a lot to Michael for coming along and sharing kind of your story and your cluster. That was great and super exciting. And I know not always the smoothest with Alpine, but that's definitely an area that we're super happy that you're working with us on, and we hope to improve in the future. Actually, I have a couple questions, so I'll start with that one actually, which is how is life with Nomad on Alpine today? And what would be the things that are highest priority for you that we could do to kind of fix that or improve that story?
Sure. So life on Alpine is pretty good. Easily the biggest thing is we can't actually use HashiCorp provided builds. We have to compile from source because we need to apply the no NVIDIA build tag. The NVIDIA driver relies on glibc lazy loading behavior, which is not really the greatest on glibc and just doesn't exist on muscle.
That's right. Would a Nomad Lite distribution where it had no built-in plugins and kind of forced you to manually install the plugins you wanted be an option for you, be an appealing option for you? Because that would obviously get rid of the NVIDIA concern. We could build without that baked in and hopefully ship a more cross-platform compatible core library, but it would be more operator work, on the install side.
Yeah, I would say it's a significant amount of work actually to every time a release comes out, compile from source. So to have a Nomad Lite, I would absolutely trade the operator effort of installing plugins to no longer need to go figure out the magic to compile this particular version.
Yeah. Sorry.
To extend on that, one of the biggest things that could be done in that world to make life on Alpine or really just life on not Debian easier would be smoke test builds. We had a really fun experience back in 0.9, which was an eventful release series for other reasons, where we had a failed to build from source. And that really was an interesting day where we had to ask some very hard questions about the reliability of our cluster stack.
Oh yeah, yikes. Yeah. Yes. 09. A lot of lessons were learned in the 09 series for all of us, I'm afraid. And hopefully we don't have to learn them the hard way again. So
we're actually still on 09 in prod.
Oh dear. Oh, there's so many goodies waiting for you.
There are. It's just a little hazardous to migrate right now.
Sure. Totally understand that. So another thing, though, I wanted to ask about too is something that we discuss a lot internally that I don't think we've really taken it to the community before. But I actually kind of noticed you touching upon it a little bit is the bootstrapping problem for the Hashy stack. And I noticed on the resinstack.io, it's listed the #1 known limitation is bootstrapping the Hashy stack. Yeah, maybe I'll let you kind of explain what that is. And if you have any ideas, asks, or particular pain points in there that you want to illustrate, it's something that we're talking a lot about trying to improve.
Sure. So actually, the article you referenced, I wrote late last night when I realized I had a bunch of unpublished draft articles that needed to go up. The bootstrap problem is especially fun for BetterHelp because we run a hyper-converged control plane. On just 3 machines, we run Consul, Nomad, and Vault. So we do some service restarting gymnastics to front load keys as we're bringing up clusters. We recognize this is not a particularly supported configuration, and we're moving away from it as a result of the problems we have. To that end, though, easily the biggest problems we run into tend to circle around access control lists, Consul really being the linchpin. So we can bring up Consul, we can set up the gossip encryption with it, and it'll auto cluster. But then Nomad sits in this weird, mostly broken state for a couple of minutes while we front load ACLs into Consul, generate tokens, and then cycle all the Nomad agents. Within the resin stack, we actually wrote custom software to do this, where it will poll an external secret store. Because this early in Bootstrap, you can't use Vault. Vault isn't live yet. And then once it had all the secrets it needs for a particular service, it just bounces it. And then very importantly, that service exits so that it cannot bounce things once we're bootstrapped. So I think probably the biggest thing that could help is for some of those things, if that could be done online, that would be a major win. We can't really bootstrap the Consul ACL token online. That's buried deep down in a vendor library. But the big one for Nomad is the Vault token. So the Nomad servers maintain their own Vault token, of course. And having to wait until not only Consul is up, but also Vault is up to bring Nomad online is a really interesting bootstrapping story, because in my environment, at least, there are some tasks that we would really like to deploy on Nomad very early in the bootstrap process, In fact, I'd love to run the Bootstrap controller on Nomad, but I can't do that when it depends on these other services. And to a point you raised yesterday during the Nomad office hours, it's an interesting question where people want to say, what is the foundational service? Do you start with Consul and then everything talks to Consul? Or do you start with Nomad and you run everything else on Nomad? And my organization went with the answer of Consul is the foundational service. It was the thing that allowed us to peer data centers, and it just made more sense for us. But I definitely see the argument to go the other way, and I could see how it would make this problem easier.
Yeah, that's perfect. That makes complete sense. And the good news is that there's work in progress to start improving this. I know on the console side, and there's kind of a running joke inside HashiCorp. Nomad often steals directly from Consul. We let them do the hard work. So hopefully we'll be stealing from them and improving our story as well. But yeah, the Vault token issue is a real one, and I know. Yeah, people have had to come up with all kinds of their own solutions around this, including things like running a parent, a hyper cluster of Nomad, but basically at the end of the day, it's a Nomad within Nomad story, where you basically have your infrastructure Nomad cluster that runs everything else, including your application Nomad cluster. And while that works great for some people, that is just a layer of overhead we don't want to force people to go down. So yeah, that's really good feedback. And I also, you actually touched upon the other question that I wanted to ask already, which is the internally, I like to call it the Hashi tax, the fact that our documentation, our suggested deployment is at least three Nomad servers, at least 3 Consul servers, at least 3 Vault servers now that, Vault has Raft and all that. That's a lot of servers that we ask people to run all the time, to maintain all the time. So yeah, it was really interesting to hear that you run them hyper-converged. I would love to know what you're moving to and just kind of your experience with that in general. And if you have any ideas on how we could lessen that burden. Because obviously it works hyper-converged. Yeah, I'll shut up and let you talk.
Sure. So I'll start off with saying when we did the initial cluster rollout, it very much was a tax. And at the time, we were not running very many worker machines. So running as few as possible machines that weren't running revenue generating workload was a business decision. As time's gone on now, we scaled up massively as everyone became stuck at home. It turns out this is something that a lot of people don't handle quite as well as they might have hoped. When we're running 80 service machines, 9 more servers doesn't really impact. So some of the things we've noticed while running this is we often refer to a concept of machine criticality. If I lost that machine right now, how bad would it be? And we refer to this both with application machines that perhaps we didn't understand constraints well enough and we wound up with a dozen cache nodes on them, or things where the control plane perhaps is we have every leader is on the same machine. That's a problem with the hyperconverged stack. And to that end, we are concerned that running the hyperconverged control plane, while fiscally less of an issue, and while as a mental load easier to reason about, you lose one server and you've potentially lost the entire Raft quorum across 3 different services. The other major reason we're moving off of this, and we are moving to a pattern where we have separate server pools. Now, as we don't run Vault in a Raft configuration, we use Consul as its backing store, we will scale that down to a more reasonable size based on usage. What we've noticed, though, is that across HashiCorp, there are very much different teams, and they each have their own release cadence, and they each have their own way they ship binaries. And so we wound up with either what we referred to internally as the dreaded triple, where we would need to upgrade Nomad, Consul, and Vault in a single maintenance window, or where we would have just the marathon triple, where it was usually 3 maintenance windows in a week. to bring everybody up to the latest version. And that's actually why we're still on 0.9, because it was a very eventful maintenance window, and we kind of said, let's not do that for a while. So it was let's look at what the next plan is going to be to update. And part of that plan involved make the updates less critical.
Yeah. And how nice would it be if you could just use Nomad to do the updates to the other projects?
So I will say, in my past life working for Google, one of the things that I thought was super cool was running Borg on Borg. And that was one of the things that I was really surprised that Nomad didn't have that functionality when I first looked at it, that you couldn't put a Nomad master on Nomad.
Isn't that the setup that Roblox is using though? Aren't they running Nomad on top of Nomad?
It is. It is. People do that. You're not going to find it in our documentation.
So they're doing something slightly different.
Oh, okay.
Okay.
Please, yeah, go ahead.
They're doing the infrastructure Nomad and the application Nomad. I'm talking about the self-bootstrapping path where you have a single Nomad server, bootstrap a bunch of clients, and then your Nomad masters become auto-migrating tasks running on Nomad, so that at that point, you no longer have special machines. That
sounds cool.
Yes. Yeah. That's that is definitely an ability that we're interested in.
Looking into what it takes to do that, though, I have so much more respect for the team at Google that made that happen there.
I was gonna say, I don't. It's been a long time since I've actually read the Borg paper. Did that functionality actually make it into the paper, or was that focused more on the scheduler design?
So the paper, as far as I'm aware, talks much more about the academic design of the scheduler. Yeah. And this was something that was just a passing reference in the bottom of a Kubernetes deck of like, oh yes, by the way, if you run the whole thing on top of its own workers, your machines aren't special anymore.
Interesting.
But you pay a heavy premium to do that. It means that your bootstrap story becomes very interesting.
Yeah.
That's
okay. Cool. One more question for you, and then I'll leave you alone. I promise. The other thing I was wondering, Thomas Weber is a Nomad user, great community member. He created the Nomad Podman driver, and we're taking a look at it right. Podman, for anybody watching who's unaware, is another container runtime like Docker. It's highly Docker compatible. It should feel like Docker in just about every way, except there's no Docker daemon is one of the significant changes. And I think they're running as containers as non-root story is really good as well. Those are, off the top of my head, the two big benefits I can remember. Anyway, we have this great community driver. We're looking into how to support it better right now. Is that something that you would find useful, you would be interested in, or does the Docker daemon kind of meet your needs today and you're not interested in changing out more things out from underneath your stack?
Oh no, I always love to ask, why did things become standard? I've been following the development of that Podman driver very closely, actually. One of the long-term stretch goals we had was nothing in our stack actually requires to be run as root. So having Docker run as root and then needing Nomad to run with elevated privileges, it's an interesting security story, especially where you have self-service job management, where if somebody really wanted to with a Nomad cluster, I don't think you could do this in ours. We have too much in your way to do that. But you probably could get a root level task running out on a machine if you configure according to what's in the learn.hashicorp.com guides. An interesting thing we actually don't run Nomad as root even now. We run it with cap sysadmin, which might as well be root, and then a handful of other capabilities that let it talk to the Docker daemon. So that and of course, once you have Docker, you have root. But we didn't like the idea of running the control plane as root.
Yeah, absolutely. That makes total sense and would be, a great goal for us to make that potentially the default, or at least something we more explicitly document and support.
To hook into that, Michael, Schmeigel Michael.
Yeah,
there's a question from the chat. If the So is there an official Podman support yet? And is it in the pipeline? So you touched on this briefly, but maybe you want to elaborate on it.
Yeah. Right now, it's not officially supported. Right now, it's still a community driver, but we're actively talking with Thomas. We're actively figuring out what that would look like to make it officially supported. So it hasn't happened yet, so I don't want to make any promises. But yeah, we're definitely working with him, and he's been really great. So yeah, hopefully we'll have some exciting news on that front here in the next few weeks.
Another question about Chris's talk. I see there's a lot of people asking about the Spinnaker Nomad provider. So the Spinnaker Nomad integration, is there any information on that yet? Or is there somewhere where people should stay tuned?
I'm working on it. I stopped working on it so that I could work on this talk. So that's actively in development. We didn't want to have to fork Spinnaker, and we didn't want to have to get these changes into upstream. So what we're doing is we're working with the Spinnaker maintainers. We're working with some of our partners. We're working with Armory to allow to get the changes into upstream Spinnaker so that we can do the Nomad Spinnaker cloud driver and all the other places in Spinnaker that we have to touch. So we can get all that done as a plugin so that you can actually just deploy that along with your Spinnaker deployment, wherever that happens to be. So it may go just a little bit slower that way, but it's gonna make it a lot easier for us to maintain in the long term. So, but that work is actively under development. It's literally what I'm going to start working on tomorrow when I get back to work tomorrow. And it'll be done. It'll be open source. The repo is not open source yet because there's not a lot in it, but it will be an open source, officially supported HashiCorp thing. So
cool. I think this question is for you, Michael. Do you have any persistent data in like running on top of Nomad? And if so, how do you manage that?
So we don't have data that is persistent in the strictest sense. We do have a very, very large distributed cache that if we lost it, it would be painful for a day or two while the cache refilled. For the little data that we do have that needs to be somewhat persistent, we bind mount in directories from the host and just write to disk there. Running on 0.9, we don't have container storage interface available, but that is definitely a feature I'm excited about to see, what can we do with persistent data workloads?
I don't remember exactly anymore. Does 0.9 already have the host volume support?
I believe they were tech preview at that point.
Okay. So you're not using that to mount it in, you're just bind mounting it.
It's just a Docker bind mount.
Okay. Another question, and I'm assuming that's also for you or for the entire panel, whoever wants to pick it up. Could you potentially use Nomad to deploy router configs and restart routers in blue-green by monitoring a centralized control plane? Who would like to take a stab at that?
I can take a stab at that, actually. So
Cool.
in doing a lot of stuff with Alpine and Nomad, I've done a lot of conversation with the team that runs Alpine's distribution infrastructure. We've looked at what it would take to run Alpine on top of Nomad, and one of the really cool things they do is they use DMVPN to do a multi-point spanning virtual network across their surprisingly many number of servers. We concluded that it's technically possible to do this. You could manage your network control plane entirely from Nomad. The problem you run into is that if your network control plane is how all of your machines are talking to each other, then what is Nomad talking on? And we started running into this problem of you now need a control plane network for your control plane. And at some point there has to be a bottom, and how you bootstrap that was not a clear question. There was also a really interesting security question around this. Well, does that mean now Nomad is root in network? That wasn't something that we really had a good answer to. So it was kind of yeah, it's possible, but is it practical?
Yep, makes sense. I also had a question because you were talking about, and correct me if I'm wrong, the OS that you're trying to move to, is that called Phoenix? Or was Phoenix just another word somewhere in that sentence?
No, so there's a set of blog articles, and the gentleman's name escapes me right now, who back in the early 2000s wrote a lot about what today we consider to be the future of DevOps. He coined the phrase Phoenix server. The idea that your server will rise from the ashes. There is no configuration management on it. If you want to change the image, just rebuild. The technology that we build these server images with is called Linux Kit. If
Okay.
you've dug deep into Docker internals, this is what powers Docker for Mac. It basically, from nothing, builds a system image, and it can do this for most major cloud providers. It can spit out things you can pixie boot. It's kind of a Swiss Army knife of building distributions if you can get your source artifacts as Docker file systems.
Okay.
Or even OCI file systems.
So basically the entire OS would then be Docker images,
Yes,
or container images.
Right, though they don't actually run in Docker. It's distinct from how something like Flatcar Linux works.
Okay. But would that mean that Nomad in your eventual use case would then also be running in this manner?
Yes, so Nomad being odd man out within the Hashi stack to not have an official Docker image, we build a custom Docker image that contains Nomad. We shove that into the image, and it's actually run directly under run C.
Okay.
So on init, there's about a 50-line script that bootstraps run C, loads some config into it, and launches the other tasks. The whole system is namespaced. So Nomad is actually not in the namespace where it can see Docker.
Okay.
We have some loop-mounted sockets that allow Nomad to see the partition of the image that has Docker in it, but not the other way around.
Okay, that's pretty
So
cool.
it very much is the kind of thing now where you might be able to compromise a task. You might even be able to compromise the entire Docker domain in this image, but it would be very, very difficult. You would need multiple levels of container escape to get the whole machine.
Wow, that's nice. I need to take a look at that.
Well, hopefully I can hastily write some more documentation before you do.
Okay. So is there any question, Michael, that you would maybe, now you have a bunch of engineers here, that you would like to ask the team directly?
Sure. I think the biggest question I would ask is, so Nomad still has this concept of management tokens. And this is something that's caused us a lot of grief with trying to bootstrap clusters automatically or use Vault integration for identity. This is actually even a problem in our existing production clusters. We have to save these tokens actually in a safe. Is there a plan to kind of get rid of that and go more towards the capabilities-based system that Consul seems to have adopted?
Who's gonna take this one?
I'll actually just poke that question a little more and then send it to Michael Schurter. But I guess the thing that would be necessary for getting rid of management tokens would be to make sure that all of the things right now that are currently only possible with a management token show up in the fine-grained ACL system. So we have a list of those, right? We've identified a couple of those over the period. And it's just a matter of making them accessible via ACL. So what do you think?
So the short version is, boy, we'd love to do that, but that's, it's not on the roadmap yet. The long version is there's kind of three related concerns here, or even features here that we're all kind of thinking about and working on orthogonally, but I think they're related, and we'd like to kind of tell one cohesive story with them eventually. The first one being getting a better SSO story for authenticating against a Nomad cluster. That's something that I think we're going to be able to piggyback on some more Consul is doing in that area. And that'll just do things like, make it so you don't have to copy and paste a token into the Nomad UI, not have to, copy and paste a token into an environment variable, all that sort of thing. A nice SSO flow for operators to start interacting with the cluster. Not related to the management token yet, but that's kind of one aspect of authentication that we're working on actively. The next aspect is kind of, you can kind of think of it as the next step kind of in an operator's workflow, would be Nomad doesn't have service accounts for jobs. We allow you to specify vault policies for jobs and, allow you to get credentials based off of those and that sort of thing. And that is incredibly useful, is incredibly powerful. Everybody should be using it today, but it's not a service account. It's not an identity for each allocation running in your cluster, for each instance of a task running in your cluster. And so we know we need service accounts, and it's definitely something that we're sketching out, trying to figure out the right shape for that. And then this kind of third effort, would be a more capability-based approach to authentication within the Nomad cluster itself, not for services, not just for SSO, but for the authorization once you're actually operating inside Nomad, a more capabilities approach. And why all of these might be interrelated is we might be able to use something like JWTs, or an idea similar to macaroons from Google, where you kind of can have a single, I'm not going to use the right terminology here off the top of my head, but a single credential blob to represent your capabilities. It's signed, it's secured, and can kind of use that throughout a workflow where you get this thing via SSO. An operator never has to see it or use it. It gets passed along through the CLI to the API. The API knows what capabilities to look for based on the operation that you're performing. At no point is there any need for it to look up an actual token somewhere. It can just check that there are signed capabilities available. And then we might be able to use those capabilities for the service then as well, once those services get deployed as part of that service identity, where if the person submitting the job has access to services A, B, and C, and they're deploying service D, well, great, let's pluck out those three capabilities and carry that down the line. So I'm sure anyone with deeper knowledge of these systems off the top of their head might be cringing at my very high level, rough description of them. But I wanted to kind of paint this picture of what we're thinking about to kind of overhaul our entire credentialing, authentication, authorization system. It's not going to happen overnight. It's not going to all land, in one big chunk. I think SSO will kind of be the first chunk. Service accounts will probably be the second chunk. And so that means doing something about the management token is going to come last. But we'll get there. We'll get there. Because it's kind of the MVP, right? A management token is kind of the minimum viable product for this sort of thing. It's like, oh, we need some root of trust here. Okay, we have a root account, and it's not ideal.
When
Cool,
you say service accounts for the tasks, will that also be leveraging what Consul already somewhat does with Connect, like giving services unique identities? Or
so it's how all of that will interact is definitely what is work in progress right now, because we obviously at HashiCorp we want you to, the Unix philosophy is at work here. Each product kind of has our own lane. We want to stay in our lane. The service accounts is definitely an area where there will be some crossover between Nomad and Consul, because like you said, Consul already has this idea of service identities. And so exactly how we relate those two identities is still being designed. And so yes, we're going to make sure to take that into account, but we haven't figured out exactly what that'll look like yet.
All right. So if I'm not mistaken, we are at time. Is that correct? It's because of the time zones I'm confused. Yes, I see people nodding. Okay. If there are any further questions, you might want to head over to the Discuss forums. So that's discuss.hashicorp.com, where you can ask any questions on any of the products. We're checking those frequently. And there's also a lot of very helpful community members that answer a lot of the questions there. Thank you, Schmeigel, for posting the link. And then, of course, there's learn.hashicorp.com if you want to dig into some of the HashiCorp features, which Schmeigel is typing the URL of now. I assumed.
Wait, whoops. You got ahead of me. What am I typing now?
Oh, I thought learn.hashicorp.com.
On it.
It looked like your typing face.
I'm madly copying and pasting everywhere I can.
Oh, that's okay. And then, of course, we will be having HashiConf Digital in June. So keep an eye out for that. There's also going to be training sessions there that will be very interesting for a lot of people. With that, Michael, thank you so much for sharing your story and the very interesting use case. I've never thought of using Alpine as an actual OS for everything outside of containers. So that was very insightful. Thank you, Chris, for your talk, and everybody on the panel, of course. Thank you so much. With that, have a good day, all of you,